Hey David. Alright, so let's begin. So your task is to design a voltage divider using some resistors to obtain a voltage of 4.85 volts. And I'm guessing you're using a 9-volt battery, so that's what I have going on right there. And so basically you have two resistors that's going to be your voltage divider, and you're going to measure the voltage of either this resistor or this resistor, and it's going to give you 4.85. Now, initially, you don't know what your resistors are, right? So it's just basically what you have is this. But you do know what the other voltage of the resistor is because you can take the 9 volt and subtract it by the 4.85 volts to obtain 4.15 volts. All right, the next task is to choose the resistors, which is the hard part. Now, I don't know the resistors in your lab kit, so I went ahead and just chose one, and I chose a 1 kilo ohm resistor. Rotate that in there. Okay. So what I did first was that I figured out the current that's going to go through the entire circuit. That's going to be really easy. Using Ohm's law, which is I is equal to V divided by R, we do 4.85 volts divided by 1 kilo ohm, or 1,000 ohms, which is going to give us approximately 4.85 milliamps. Now, since we know the current that runs through the entire circuit, we can also easily find the resistance of the second resistor that we don't know using Ohm's law again. So we're going to go ahead and do R is equal to V divided by I, or 4.15 volts divided by our current that we found, which is 4.85 milliamps, which is going to give us a resistor approximately to 855.67 ohm resistor. Now, I don't know if your lab kit carries that, and probably they won't, which means that you probably have to readjust this value here, 1 kilo ohm, to maybe something else, like maybe 1.5 kilo ohm or like a 2 kilo ohm. You have to keep on trying different combination, basically. So that's your task there. And then also they have a constriction, which is the voltage divider has to be greater than 0.1 milliamps, which we've already satisfied here, because this is going to be greater than 0.1 milliamps. We have 4.85 milliamps. The third constriction is that ensure no resistor is overloaded. So what that means is that the power, if you look at the resistor sheet, it should have like resistor should be like it should say like 1/4 or something like that on the data sheet, or like a half or something like that. That is referring to the watts. And you get power from the equation of voltage times current. And so to ensure that we didn't go over the maximum rating power for the resistor, we can simply do V times I to determine that. So basically I took 4.85, which is the first resistor's voltage, times the current, which is constant throughout the circuit, which is 4.85 milliamps, and I got around 0.235 watts. And if I remember correctly, some of the resistors were 1/4 watts, which is 0.25. And so since this is less than 0.25, this should be okay. This resistor might be a bit warm, but definitely not overloaded. And so I can do the same thing with the second resistor. I would take 4.15 volts times the same current again, 4.85 milliamps, and I get around 0.02 watts, which is definitely less than 0.25 if our watts is again 1/4.